Question number 31, which is from the chapter Real Numbers. We have to prove that root 3 is irrational. So we use a contradiction method in order to prove this. So what we do here, so first we took a let statement, right? So what we will say, let's say, let root 3, okay, I'll give space here, be a rational number. That means I took this, that root 3 be a rational number, right? We know it's an irrational number. As I said, we are going to use contradiction. And you know that any rational number should be, any rational numbers can be written in the form of P by Q, where P and Q are co-prime. That means they do not have any common factor between them. And Q should not be zero because any number divided by zero is not defined. And at the same time, P and Q are co-prime. Co-prime is what? They do not have any common factor. Let me highlight in this, as we are going to use this idea that they are co-prime. They are co-prime. All right. Now, if I do cross multiplication, I can say this is root 3 times Q is equal to P. Now, if I do squaring both sides, so we'll get 3 times Q square is equal to P square. So what does it mean? 3 times of Q square is equal to P square. That means that P square is divisible by 3, right? So we know P square is divisible by 3. By 3. So when a square number is divisible, the number is also divisible. So P is divisible by 3. Now, in the next part, we are going to consider, let's say, we know that here P is divisible by 3. So we can write that P is some multiple of let P is, it is some multiple of 3. So I can write, say, 3m. Now from this equation here, I'm going to replace P with 3m. So it's going to be what? 3 times Q square is equal to, replacing P with 3m. This is 3m whole square. That is, it's going to be 9m square. Let's reduce it. This is 1 time. This is 3 times. So here we can say that Q square is equal to 3 times m square. So what do you conclude? That Q square is some multiple of 3. So that means Q square is divisible by 3. So it implies that Q is also divisible by 3. Now check here from these two, what do we conclude? That P square, P and Q both are divisible by 3. So from here, these two, we can say that P and Q has at least one common factor, right? P and Q has at least, right? 3 is a common factor of P and Q. But we have taken this as co-prime. As I said, co-prime is one which do not have a common factor. So finally, you will say that this leads to contradiction. I don't have space. You said right on. This leads to contradiction that root 3 is rational. So if root 3 is not rational, you know that a real number can either be rational or irrational. So since it is not rational, it has to be irrational. There is no third way. So this is what you need to write down.